In our last video, we set up a relay system to allow projectile and asteroid interactions. When a projectile collides with an asteroid, the asteroid and the projectile explode as we expect. But what happens if we have a bigger asteroid? Say this one. We would sort of expect the larger object to take longer to destroy. Not the case. But a health system would fix this problem. But if we implement the health system directly into the asteroid, it will work only for asteroids. What about ships, stations, and a myriad of other object types that could benefit from a health system? Enter components. Components are a great solution for this kind of situation. In fact, components are a great choice for any type of situation where you want to mix and match behavior objects. Engines like Unity have a very nice built-in component system for this very reason. Unfortunately, Godot 4 is not exactly a component-based system. So what does Godot 4 have? Inheritance, it is useful in game development. It's useful in a lot of very specific use cases. Godot uses it extensively to define the basic behavior of its nodes. For instance, I can inherit a class from Character Body 3D to build a controllable player character. But inheritance also has significant drawbacks. It only works in chains, so you could end up with deep inheritance chains as you are attempting to reuse your components. Even worse, you may need to combine different sets of behaviors onto your node which cannot be easily expressed in terms of inheritance. So what can we use instead of inheritance? Well, obviously, the answer is components. But we'll define our components in terms of nodes, which we can attach as children to their parent node. This child component node will help define and control the behavior of its parent. In this way, we can mix and match nodes just like we could components in other engines. Component nodes can have properties and functionality specific to their job. Best of all, this method is fairly simple to implement. It'll be a great solution for our health system. First, though, let's get an idea of what a basic component would look like. At its heart, it's just a node, and as we can see here, that's all it's extending from is node, the very basic node, in fact. No frills, no bells or whistles, just node. What we'll also have is some sort of a source object. This typically comes from the parent. It doesn't have to, actually. You could have this as an export, and that export would then pick up from or whatever you assign it in the editor. And this could add a degree of flexibility in your component system. However, as a general rule, I like to set my source object to be its parent just so that I can have a snap-in solution. I find it to be easier and less accident prone in case I accidentally forget to assign said reference in the editor. In this particular example, all we're going to be doing is just doing a rotation for a 3D object. So we're going to store an Euler rotation. And the important thing to note here is that since it is a node, you can provide export vars, which can be set within the editor for that particular component, whatever your component may be. For instance, in our health system, once we get to it, we'll be storing our health current value as well as the max value. And then in our ready, we want to assign our source to our parents. In my typical use case, this is how I would do it. And then as an added precaution, we want to be sure that the parent is a node 3D. So if we use the as clause for node 3D here, this will attempt to retrieve the parent as a node 3D. If it's anything else or null, source will also be null. So we can do an assertion to check and make sure that source is different than null. If this assertion fails, we'll get this printout that says parent should be a node 3D. And by doing that, we'll be notified that we've attached our component to the wrong parent type. Sadly, there's no way to do this, and well, that may not actually be true. There is a way to deal with this in the editor. It's a little bit complicated. Maybe I'll do a future video on it, but for now, this will do. All right, and from then on, it's just do whatever you need to do with your component. In this particular case, every physics tick denoted by physics process, we're just going to rotate our source basis. So this will be our parent object in the case. We're going to rotate it based off our Euler rotation, which is specified up here. And that's it. That is a basic node component. They're very simple, very versatile. All right, so let's expand this out to our health system. And if we do so, we're going to create our health object, or health component, I suppose you would call it, and we're going to give it a name of health. Again, this is just going to extend node, nothing special about it. But the cool thing is this will be able to attach to any other object that we want in the game. Doesn't matter what type it is, we're not doing an assertion check because we really don't care. All we want is our health system to manage the health of whatever it's attached to, and that's it. We're going to define a couple of signals over here, changed and killed. Changed will be called anytime there's a modification to the health, and killed will be called anytime the health changes and the health has hit 0. We're also going to later on lock our health so that we can never go below 0 or above a maximum health, which is defined here. And then we can also set our current health as well. This can be useful in particular contexts where maybe you want an enemy, maybe for scripting reasons, or what am I trying to say, story reasons, may not start with maximum health. You can set it manually from the editor. In our ready, we're going to move our relay receive. This comes from my previous video. If you're not sure how relays work and would like to set up your own, you can do that. And my previous video on relays will teach you how to do that. It's not too complicated and it's incredibly reusable. So I do recommend checking that out. I also want to state that the relay system is not at all required for a component system. The component system is very generalized. I just happen to be using relays because they're very useful right now. But in our previous example, or our previous tutorial, we attached the projectile collision message directly to the asteroid. We are going to remove that from the asteroid and we're going to move it to the health instead. This has the advantage that anything that health attaches to will automatically react to projectile collision messages, which is pretty awesome. And you'll notice that the receiver of this relay is going to be the parent of the health node. And so if we attach our health node to an asteroid, that means the asteroid will be the one receiving projectile collision messages. And as usual, we're going to have a projectile collision callback, which we'll define below, and that will handle our collisions directly. For now, we're also going to set our health. That basically just makes sure that our health is within the proper range. And here is our projectile collision callback. And all we're going to do for that is we're just going to adjust the health by the negative projectile damage, because we're taking health from the projectile. Essentially, we're applying a damage effect to the source or the parent object. All right, from then on, I'm not going to go too much into the explanation, but I will leave this slide up for a second. Effectively, set health is setting a new health, and it's just locking it to the health bounds. Health must be between 0 and max health. If there's a change, or if there's no change in health, it'll return early. If there is a change, then it's going to emit the change here as a signal, including the new health value. And if the health is less or equal to 0, it's going to emit the kill signal, allowing our parent object to know that it has been destroyed. These do need to be wired up manually, but we'll get to that in a little bit. There are ways, of course, this is my design, but there are ways, of course, to send this information to the above object without having to manually hook these up. One way is to send a killed relay message to the parent and then have a function to deal with it there. But there are options, so do whatever works best in your particular case. Set max health basically is just setting the maximum health, and then it force sets the health when it's done, just to make sure that health fits within the proper bounds. And finally, we just have our simple adjust, which just sets the health to health plus whatever amount we pass in. And that's basically it. Now, if we go check out our asteroid, we need to make some modifications. Specifically, the only modification we really need to make is we need to remove the relay, the receiver relay. That, as we saw earlier, if we go back over to our health, we're back in health. That's handled within the ready of our health object, so we no longer need to handle it in our asteroid. In addition, if you have modified the previous tutorial and began adding relay receivers for projectiles to other objects, and you also plan to add the health component to them, you also don't need the projectile collision receivers in those objects as well. So you can go ahead and get rid of them there. So effectively, this is basically our asteroid as it looked the last time, but now it's devoid of the relay, and that's essentially it. So now we need to wire up our signals, and to do that, we are going to go back to the editor. We add our health component. I actually should have put a slide in for that, but essentially, you're going to right-click on whatever object you want to apply health to, add a child node, and then select health from the list and press OK. And that should add a gray circle node for health underneath that particular object. Then when you click on that, next to the inspector, I should say, there's a node button. You'll want to click on that and your signals should show up. You would double click on the killed signal, and then you would go to, and I need to specify real quick, this shows a signal that's already been hooked up, so you see the destroy underneath it. You won't see that initially. You'll just see the killed, and that's it. So go ahead, double click your killed, and then what you would do is on the left-hand side, you'll be presented with this dialog. Select your asteroid. In this case, it's going to be asteroid large, and then select pick, and then select destroyed, hit OK and connect, and you should be all set up. So now, if we go flying off this way over here, I've got a big asteroid that has a proper health attached to it. And so again, for the littler asteroids, one will do because they have a little bit of health, but the bigger ones have much more health. And there we go. And that's basically it. You now have a health component system. But here's the cool thing. You can actually set up, whoops, I forgot to rename this slide. Anyway, our our component system can now be mixed and matched with other components. Our ship node has multiple components, as you can see. It has a health component, it has a player controller, and it has an aligner. So as you create brand new components which do different things, you can just mix and match them together on a node, and it will start picking up the behaviors of each of those different component nodes. And that's it. There's not much else to say, so I hope you guys learned from this. Consider liking and subscribing, and I'm very excited to keep creating new videos for you guys. Still getting used to this whole format, so let me know in comments if there's anything else you'd like to see or like me to change or maybe specify a bit. But that's effectively it. So thank you guys for watching. I'm looking forward to seeing you guys in the next one. Have a good one, and God bless.